Just to just to just to be sure, please raise your hand if you can hear me. If you can hear me, please raise your hand. You can raise your hand with the reactions here in the Zoom application. Okay, Gerald, good. The other ones, can you hear me? Please raise your hand. David, okay. Ivan, Medar, Evelyn, can you hear me? Please raise your hand with the reactions. I'm going to start if you raise your hands. We have the reactions here in the line, in the bottom of the applications, and you can raise your hand like this, or you can do this, wherever you want. Okay, Evelyn said, I can hear you. Okay, let's go. Mm, Let me show my screen. Okay. This is the model we used in the previous session in order to study what Wellments are. So if you remember the key topics we studied at that last session was first, multibody. What is a multibody file? What is the difference between a multibody and an assembly? So if you remember, a multibody is a collection of bodies that are inside a single file, a single part file. So in a single part file, we can have these several bodies, as you can see here. So this is not an assembly, this is a multi-body part. And we can have assemblies with multi-body parts. So we can have this mixed assembly, and the other thing we studied is the fact that in a multi-body part, we can have three types of bodies. Do you remember these types of bodies? Can be standard bodies. Those are bodies that you model using the standard commands, extruded, revolved, swept, loft. Okay, those are standard bodies. The other kind of bodies you can have in the multi-body part are sheet metal bodies. Those are bodies that you model with these commands. And those bodies have special parameters and special characteristics. They have thickness. They have a key factor that is used to flatten the part. And those parts can be flattened in order to work out how many, what are the dimensions of the sheet you need to produce that part. And the other kind of bodies you have in a multi-body part are structural bodies, as we can see here. These are structural bodies, and you model these structural bodies with these commands, with the commands you have in the Weldment tab on the command manager. This is the command manager, and these are the tabs. So the thing is that these structural members have special characteristics. For example, they have a profile. So that profile dictates the shape of the middle section of each structural part. okay? And you can have your library with many of that structural profiles in order that you can select, let me show you here again. You can select, as you can see here in my screen, you can select which is the profile you are going to use to model the structure, okay? That's the first characteristic that these structural elements have. The other characteristic is that these elements have joints. As you can see here, these are the joints, okay? Uh, and you can have, and you can sketch and sketch, sorry for the redundancy, but you can have a sketch that conforms the schematic of the structure. So if you need to make changes of the structure, you can change the dimensions that are into the sketch, as you can see here. Okay, and that is important to understand because as you know, we need to insert, or we need to define the design intent even before we started to model, okay? And we define the design intent into these kind of structures through these sketches, okay? So that's the important thing. And to sum up, in a multi-body part, we have these three types of bodies, okay? And we studied also the way we can insert these structural members. We have here this command that is called structural member command. And in this command, well, we first select the profile we are going to use, and then we select for each of these groups you have here, we need to select the lines that are going to be used as guidelines for the structural members. Why we have groups here? If you remember, the system, I mean, SolidWorks, allows you to put in the same groups just the elements that are, number one, um, parallel as this and as this, or the other rule is you can put elements in the same groups that are connecting by an endpoint, as you can see here, okay? And just let me show you a special point, a special key point of this. Um, Look at this group number 3. This group number 3, it seems that there is a connecting point here. And you can ask why this element is not in the same group as this if we have a connecting point. And just to clarify, this is not a connecting point because this point is not is not splitting this line into two elements. If this point was splitting this element into two lines, this could be defined as a connecting point, but in this case, it's not. That's why we need to put this element in one group and this element in one group, because neither both um, follow one of those rules I said. Okay, these lines are not parallel and don't have a connecting point in common. Okay, Well, and in this session, we are going to study joints, how to manage the joints, okay? And the other thing that we are going to study uh, is uh, how can I manage a cut list, okay? A cut list, we are going to see that it's a special way to manage all the bodies that I have in the multi-body part. And the other thing we are going to study are drawings. How can I make drawings of these structures? And how can I make views of just one single body? Okay, so let's start. First of all, joints. We can see here the joints, and I need to change the way these elements are cut into this upper frame. So as you can see here, we have a special corner treatment here that is called end needle. Okay, we have here in the structural member properties the corner treatments we can use for each group. So if you change here the corner treatment in the property manager, look at this, all the joints of this group are going to be changed. So these buttons are used to change the corner treatment of all the bodies in this group. But what happens if I need to change just one of the joints? Well, you can do it, or you can access to the corner treatment properties of just one single joint with these pink dots. If you click these pink dots, as you can see here, we can access the corner treatment properties just for this joint. And we can change the order of the trim. I mean, we can change the corner treatment we are going to use in this single joint, as we can see here. You know, all the other joints remains the same, and just change this joint. Okay, I'm going to do the same with this in order that all these two horizontal elements uh, are not going to be cut. These elements, these vertical elements, yes, are going to be cut. So I need to change the joints, okay? Let me do it here, and let me do it here again, okay? So if you need to change just one single joint, use the pink dots. If you need to change all the joints at the same times with the same characteristics for each group, use these buttons here in the property manager. Okay, that's all. And then I'm going to model a, a piece here, a part, a body here for the base of this of this structure. Uh, I'm going to use this face here. These bays are going to be modeled as a standard body. I mean, I'm going to use a boss. Well, let me make the sketch here, and let me put the dimensions and the relations. Okay, let me put another here, and let me put a relation here. Okay, that's all. And I'm going to use the extruded boss command here. Okay, and that needs to be 20. Okay, and see there, each time we insert a structural member command, as you can see here, the system automatically put a Wellman command at the beginning of the feature tree, as you can see here. And this automatically feature also rocket did could that could list here. So this could list help me to manage all the bodies inside the multi-body part. How these bodies are grouped according to the geometry and according to the material. So all the bodies that have the same geometry and the same material are going to be put into the same group. As you can see here, look at this. I select this, put this element here, and all the bodies that are inside the group have the same geometry, I mean the same length, the same middle profile, and the same material. And that's the case of all the other elements. And if you look at the icon of each group, you can see what is the kind of body that is inside of the group. So look at these icons here. These icons tell me that these elements are structural elements. This icon, the blue folder here, tell me that this is a standard element. And there is another icon for the sheet metal elements. So if you look at the icons, you can determine what kind of bodies are inside of the group here. Okay. Okay, let me put some holes here. Need to put some holes here. The position of the holes. Maybe you use this command more than one time. This is a really common command. So let me complete the sketch. In order to position these holes, I think that's so. Okay. Okay, we have a special commands here in the Wellman tab on the command manager that I'm going to show you now. The first is the end cap command. This end cap command helped me to put some caps on the end of the open structural members. This end is open, so in real life, I might need to put a cap in this to protect the inside of the structural member. That's why I have this command here. So first you need to select the face where the cap are going to be based, okay? And then we need to tell the system what is the thickness direction we are going to use. We have three different directions for the thickness, as you can see here. This is the correct for this case study. And then we need to put the thickness of the cap. Okay. And the other parameter we need to define is where the edge of the cap is going to be placed. In this case, we have two parameters to define the edge position. I'm going to use the thickness ratio. And the thickness ratio is the percentage that represent the position of the edge along the thickness of the structural member. I mean, this value here, this thickness ratio here, 0.5, says that the edge of this cap is going to be placed in the middle of the thickness. If I change here, for example, 0.75, look at this. The edge of this cap was placed 75% of the thickness of the element, taking as a reference the external face of the element. So let me change back the value. Okay. And also we can define a corner treatment for this cap. We can use a chamfer or we can use a fillet. Okay, let me select the chamfer and that's all. So this end cap, it is defined automatically as a standard body. As you can see here, the cap is a standard body too. Okay. The other kind of special elements in a structural member are the gussets. Okay. The gussets, we have here the gussets. The gussets are defined by supporting faces. And these gussets are used to put some strength to the structure. You know, those gussets are that kind of element that stiffs the structure. Okay? And we need to define the supporting faces between the element, I mean, the gusset is going to be defined, as you can see here. And then we need to define the profile. Okay? If you look at the peak of the profile you selected, you can clarify or you can realize what this dimension represents. You know, let me put here 150, 150. Let me put here 25, you know, and we can use also a corner treatment for this corner. I'm going to activate it and I need to define also the dimensions. Okay, the thickness here. These bottoms represent the position of the thickness according to this location point. This location point first represent the point of the edge that intersect the two supporting faces. I mean, the intersection edge for these two supporting faces is this. And we have here three location points. Two on the sides here and one on the middle. And according to this point we selected here, we can put the thickness through one side, through the other side, or through the middle, you know? And that's just to clarify the position of the gusset. And as we see on the end cap, this gusset is going to be defined as a standard body too. So the only way to define a structural member body is using this structural member command. Other way, the body are going to be defined as a standard or as a sheet metal body. Okay, that's important to know. And just to complete this structure, I'm going to use a mirror command here. And one improvement that was included into SolidWorks, I remember it was in SolidWorks 2019, no, 2021. I'm not sure, but was between 2021, 2022, is that you can define a mirror through a primary, but also through a secondary plane. So you can mirror in two directions. And before that SolidWorks version, you can't do it. You couldn't be able to do it. Okay, but now it's easy to mirror in two directions. I'm going to select the primary plane and then the secondary plane. Okay, that's why it is important that you define the design intent, because in the design intent of this structure, I defined that all the elements need to be placed uh, in the middle of these planes, you know? Okay. And let me select the bodies. In this case, we can mirror features, faces, or bodies. In this case, I'm going to mirror bodies. That's why I selected this section here. And I'm going to select the bodies. Look at this. Each, each time I selected a body, the system shows me a preview of the bodies and the position where those are going to be placed. Okay? And the systems recognize these copied bodies, and the system also put that bodies into the group that needs to be in. Okay, according again with the geometry and with the material. Okay. Okay, we completed our structure here. And what happened with the cut list? As I told you, the cut list helps me to manage all the bodies according to the geometry and the material, but also helps me to manage the properties for each group of body. I mean, if you right click on one of the groups that we have in the cut list, and then we select this properties line here, the system is going to show me the properties that are defined for each group of bodies. Let me put this here to show you. In this left section of the cut list interface, we can select each of the groups we have. into the multi-body part. And also, there is a dynamic highlight for each of the bodies that conform the group. Okay? And then in the right section of this window, we have the properties that are included for each of the groups. There are some properties that are automatically defined as long as I model the multi-body part. Those properties are defined automatically by the system, and those properties are the most common we as designer or as product engineers need on the drawings. You know, it is common that we need a length. It is common that we need an angle for each of the extremes of or for each of the sides of the structural members. I mean, the production team, the manufacturing team needs to know how they are going to cut each element. That's why we need those angles. Okay, the material, a description, and it is common that this description property is defined by the size of the profile. You know, as you can see here, the system automatically detects the name of the profile and then put that name in the description line. You know, the material, the quantity, that is other special property that we commonly use. Okay, because we need to tell the production team how many of these parts they are going to put. Okay, and the total length. The total length is used to tell the production team how much uh, how much material they need to buy to get all these good parts. Okay, I mean the raw material they need to buy. Okay, and we have these properties in all the structural members bodies on the multi-body part. What happened with the structural bodies, with with the standard bodies? The standard bodies are automatically defined with other kind of properties. These standard bodies doesn't have a length and an angle. That's why those properties are not included in this kind of bodies. But we can put another properties here, for example, weight. Well, peso means weight in Spanish, okay? And we can link this property to a physical property, to a mass property here. So we can do the same with all these structural, with all these standard bodies as, as I am doing here. Okay, so we are not limited just by the properties that the system define automatically. We can put whatever we need on the groups through the cut list. That's why the cut list, it is important to understand how to manage it. Okay? Okay. That's the cut list. And what happened with the drawings? What are the capabilities we have on the drawings for these multi-body parts? Okay, let me start a drawing here and let me select a format. I mean, wherever you want. Let me select this format, the ISO, wherever you want. It's not important for this session. You have your standards in your company. And also, well, as any other kind of part, we can put different kind of views. I mean, standard, projected, section, detail view. We can do it with multi-body part as we can do it with parts that only have one body. It doesn't matter. I'm going to put here a front view and then some projected views. Okay, let me hide the sketches here and let me place this view. Okay, what happened with the dimensions? The dimensions can be inserted in the same way you do it with other kind of parts. Okay, we put the model items. Uh, I want to I want to erase. I want to delete some of these dimensions. Okay, and let me erase these dimensions too. Because let me show you this. I erased or I deleted these dimensions because I want to define them in a single body view to clarify for the production team. Okay, and how can I make a single body view through this part? For example, I want to make a view for these base elements I modeled on the structure. How can I do it? Well, first, I need to put a view that represent the same position or the same projection that I want to use to represent the single body. That's why I'm going to select the top view. Let me put the top view here. And then if you select again the view, you put them there. And if you go to the properties of that view, you are going to find this button here. This button here is special to make to convert the view to a single body view. That's why I'm going to rocket this button here, and the system automatically shows me the complete multi-body part just to select the body that I want to retain on the view, okay? And this is the result here. So each time you want to make a view for a single one body on the drawing, you need to use this button here, okay? The select bodies button. And I'm going to change the scale. No. Let me put this. And then as you do it with common view, you can import the model items. Okay. Let me select this. Okay. If you need to put another kind of annotations, I mean, a whole callout, you can do it. a chamfer callout, whatever you want. You can do it as you do it with other kind of views. Okay, let me do the same for the gusset. I'm going to do the same for the gussets. And again, after placing the whole view, I'm going to select again the view just to rocket this bottom here. And I'm going to select one of the gussets. Okay, and again, if I want, I'm able to change the scale. Okay, I'm able to put the dimensions, half, okay, and whatever you want. What about sections, detail, and other kind of views I can insert for the whole views of the model? I can do it with a single body view. For example, this is a really easy example. I'm going to put a section view here and look at the result. The result is that I have a section view for that single body. And that's a result for all the other kind of views, detail view, remove section view, and whatever you want. Okay, so the behavior of a single body view is the same as the behavior for a full model view. Okay. Okay, let's go to the next section. And the next section is what happened with a cut list in the drawing. So the way to represent a cut list in a drawing is through a table. Okay. And in that table, we can include all the properties we define automatically or manually in the 3D model. So where can I find the cut list table on the drawing? Well, you need to go on the command manager, on the drawing command manager. You need to go to this table command, and under this table command, we can have the cut list, Wellman cut list table. Okay. And the first thing we need to define to insert that table is the view that is going to be linked to that table. In this case is the front view. Okay. And I can place it here. It is important that you verify that the table is linked to the view. And the way to do that is right-click the view that you select when you insert the table. And then you must go to the properties of that view. And inside the properties of that view, you have this section here, the balloon section. If you check this button here, you can select the table that is linked to that view. And that's important because in a production drawing, in an assembly drawing, or whatever kind of drawing you can remember, we might have more than one table. And if you don't define, if you don't clarify, if you don't make sure which of this table is linked to the view, the system automatically define which table is linked to the view. And sometimes that results in issues. Because if you let the system define it automatically, maybe that is not going to be the right table for the view, okay? That's why you need to come here to select the table you have, okay? Great. And with this table, I can change the font. I mean, let me put a bigger font here. Oh, that was too much. Let me resize the cookies here. And I'm going to show you how can I add another property on the table. Well, first of all, I need to put using right click here in one of the columns that we have in the table. I need to right click one of that columns, and then I need to select this insert section. And I'm going to select a new column. We can insert the column on the right or on the left of the actual column. Okay, and then if I select this empty column in the right side of the interface, I mean in the properties side, we can select which kind of property I want to show here in the empty column. So if you want to show one of the properties you define manually on the code list, you need to use this uh, this option here, code list item property. And then you can find, for example, the weight. Remember, peso means weight in Spanish. And I can select this property that I define manually. And those are the values, okay, we have for each of the standard elements, okay? And look at this. It seems that we have an issue here. This is not the value we want to show for this group. And to solve this, we just need to go to the model. We need to go to the properties, okay? And look at this. In this case, I made a mistake. I select not the right property for the weight, and I'm going to change it in the mass instead of the material. Let me, clear this. Let me put the property. Okay, and that's the right property here. And each change you make to the model or to the properties in the code list is going to be synchronized with the drawing. Okay, so remember, each change that you make to the model or to the properties in the code list is going to be spread to the drawing. Okay, great. And the last thing I'm going to show you is how can I link, or how can I link the the solids, the bodies with the table. We can use balloons. okay? And we can insert manually those balloons as you do in an assembly. And the number of those balloons are linked to the code list. Mm. So if you can see here, the numbers, these numbers are linked to the table. That's why it is important that you define on the properties of each view, okay, what is the linked table you want to use, because this property defines the number of the balloon that is shown in each of the bodies. So this number here is linked with this number here, okay? Well, that's all. Just to sum up what we see on this session, we started to manage, or we started to study uh, how to manage the joints. Remember, we can manage the joints individually or by a complete group. Then we studied what is a code list, what represents, how this code list helps me to manage or to group all the bodies. We studied again what kind of bodies we can have in a multi-body part. And then we made a drawing of the complete structure, and also we made some views for a single body here. We insert a put list table to show the properties for the production team, and also we insert balloons to link the views with the table. And that's the basics you need to know about Wellmans. I sent Derek some of the exercises you can make in order to practice for the certification. I mean, for the Wellman certification. Remember that, let me put this presentation here. Remember that there is a path you should follow. Let me put the presentation here. There is a path you should follow between the CSWA. The CSWA is the first step in the certification program. You achieve, well, most of you achieve right now. And then between the CSWA and the expert, this is the top certification you can achieve on the CAD specialty, the expert. And between those, there is a path you need to achieve. The next step for you is the CSWP. I mean, if you have the CSWA, the next step is the CSWP. And then you need to achieve at least 4 of these advanced certifications to have permissions to present the expert certification. Okay, so you need the CSWP and 4 of these advanced certifications to present the expert certification. And that's the goal, that all in this group can achieve the expert certification. That's why Derek is looking for speakers, and that's why Derek is putting effort on these sessions for you guys. So uh, practice, practice, and practice in order to go forward on this path. Okay. So that's all. Questions? Maybe you have questions, please